Hi everyone, welcome to my channel, Tutorial Test Prep. Today we'll be going over 7 hard problems for the August 2023 DSAT. Problem Sette number 1. The goal of the Problem Sette series is to provide an original worksheet of challenging problems right before the test date. This gives students the opportunity to push themselves while also reviewing a variety of topics. Please download the worksheet for free using the link in the description and attempt the problems yourself before watching this video. Let's get started. Okay, so the first question is asking us about a regular hexagonal prism. It's exactly what it sounds like. It's a prism with a hexagon at either side serving as your two bases. To save myself some drawing, I'm going to just, use the magic of television to kind of show you guys what this looks like. So, the first thing you need to know, and this is for any prism, and this is tested on the SAT, maybe not this shape in particular, but prisms as a whole, is that prisms follow this equation. The volume is equal to the area of the base times the height. Volume equals area of the base times the height. So right away we have the volume and height in units that agree. So we can plug those into this equation. So the volume is 350 and the area of the base we don't know. And the height is 14. So we can now go and divide both sides by 14. And we get that the area of the base is going to be 25 inches squared. So that's not our answer, but that's like really important, so I put a box around it. So each of these bases has an area of 25. So now we just have to use our knowledge of hexagons to figure out kind of what the length of each side is. Regular means all the sides and angles are the same. So once again, to save myself some drawing, I have some important stuff that I'm just going to pull over. So this is a cleaner drawing of a regular hexagon. And if you didn't know this, this is something that comes up on the SAT once in a blue moon. You can split a regular hexagon into 6 equivalent triangles. And if you do the math on this, each angle will be 60 degrees, which means that all of these are equilateral triangles. So it gets broken up into 6 equilateral triangles. So I'm just going to use maybe like, why don't I, let's say, pull out the like one of the triangles, and I'll like draw it over here. And we know that this thing has to have an area of 25 and then there's 6 of them, right? So we're dividing it evenly. So it should be 25 divided by 6. So what we're going to do is whenever we have an equilateral triangle, we're going to split it into 2, and it forms 2 30, 60, 90 triangles. So now how about before we go any further, we check the reference sheet and pull up the 30, 60, 90 triangle. And now let's see, why don't we label this guy as across from 30 would be X. Across from 60 would be x root 3. And across from 90 would be 2x. So the area of, and this is an equal one. This guy is equal to this guy. It cuts it in half. So this would also be 2x. So the area of this guy is 1/2 base times height. So 1/2 2x times the height of x root 3. That should give you root 3 x squared, something like that. And we know this is equal to 25 over 6. So at this point, I think it's fine if we just use a decimal. So I'm going to do 25 over 6. I'm going to divide it by root 3. And then I'm going to take the square root. And I'm getting, hopefully this is right, I'm getting x equals 1.551. And to find the perimeter, we want the 2x side. So 2x, that times 2 is 3.102. And if I put that on this picture, what we're now going to do is we're going to recognize that you see how we're trying to find the perimeter of one of the bases, right? So to find the perimeter, each of these sides is the same. So we're going to multiply that side by 6. So the perimeter is just 6s. So the side length is 6 times 3.102. And I'm getting 18. It wants us to round to the nearest tenth. I'm getting 18.6 inches. So that would be the answer to this one. Certainly you don't need to memorize this, but certainly what would make this problem go faster is if you knew the formula for I don't know why I can't select this guy. See if I can go back. There we go. So if you knew the formula for the area of a regular hexagon, so if you want to go back and redo it, see if that helps. Again, I don't think that's worth memorizing. You need to be really comfortable with special right triangles, and you need to know that a regular hexagon gets split into 6 equilateral triangles. Half of an equilateral triangle forms a 30, 60, 90. Think about it. They're all 60. If you cut one of the angles in half, it becomes 30. Great. Let's move on to the second one. Okay, we just went over this. I just went over this in the 806 video. So please go watch that. This is the last skill, messy standard form. So the first thing we need to do is we need to get this in standard form. So to do that, we need to clear the denominators. So this top one has denominators 2 and 4. And the least common multiple of 2 and 4 is just 4. If you get messier numbers in the future and you have a hard time seeing that, don't forget there's an LCM function in Desmos that you can use. And we're going to multiply that whole equation by 4. And this bottom one has 9 and 3. Well, the LCM, the least common multiple of 9 and 3 is just 9. So we're going to multiply that guy by 9. Great. Okay, let's come back over here. And let me erase this yellow. And why don't we do the top one first? So 4 times 5 halves, 4 divided by 2 is 2. 2 times 5 is 10, so that's 10x minus 19y equals 4 times x is 4x minus 4 times 6, 24. We're now going to get that in standard form, so this guy is not on the correct side. He should be on the left side, right? So we're going to subtract 4x from both sides. And we should get 6x minus 19y equals negative 24. I'm going to just put a box around that. That's looking pretty good. Now let's do the second one. So 9, those cancel out, so we get 89y plus 9px equals 9 times 5, 45r. 9 divided by 3 is 3. 3 times 2 is 6. So 6y. And now we're going to add 6y to both sides, which should give us 95y. And then while I'm at it, I'm also going to use the commutative property to kind of change the order. Remember, ax plus by equals c. That's what we're going for here. And let's cross this out and cross this out. And we get 45r. And I think that one's good too. So now we're going to, again, kind of, circle the constants. And this question says it has no solution. So we're going to be doing A over D equals B over E is not equal to C over F. So let's do that. So I'll just go over here. So 6 over 9p equals negative 19 over 95, which is not equal to negative 24 over 45r. And we can use this side to solve for p. So let's do that. 9 times negative 19 is negative 171p equals 6 times 95, which is 570. And 570 divided by negative 171 gives me negative 10 thirds. And it seems like that's an answer choice, so that bodes well for us. And now we're going to try to figure out something about r. So why don't we use this side? And I know I'm all over the place here, guys. I'm kind of running out of room. Why don't I do this over here? So 45 times negative 19 is negative 855r. And it's not equal to 95 times negative 24, which is negative 2280. And we divide both sides by negative 855. And we should get r is not equal to 8 over 3. And that's not an answer choice, but we can maybe do some algebra to make it look like this one. So we're going to multiply both sides by 3. And we get 3r is not equal to 8. So that means 4 is true. And the answer is 2 and 4, which is B, this one. Whenever you do a problem like this, even if you do it by hand, if you have time at the end, you should go back and type the original question into Desmos and see if it makes sense. So let's do that. And now I'm going to do 89 over 9 y plus px equals 5r minus 2 divided by 3 y. And I'm going to do p equals negative 10/3. And now I'm going to do r equal to, let's say, 8. And let's not graph that. Okay, so p is equal. Okay, so this looks good. This looks like it has no solution. I just picked 8 as an arbitrary number. I believe we got 8/3 is what r cannot be equal to. So let's type in 8/3. See how when we make r 8/3, it gives us infinitely many solutions, which is not what we want. But if r is anything else, like if I did like -4 or something, or -10 or 25, it would give me no solution. So as long as r is not equal to 8/3 and p is equal to -10/3, we will get a system with no solution. Looks good. I think we did a good job. Great. Let's come back over here. Okay, so this is called radicals with mixed indices. First thing I'm going to do is I'm just going to know my power table. I'm going to know like what powers give me 2. So like 2, 4, 8, 16, 32. 4 would be 4, 16, 64, stuff like that. 5 would be 5, 25, 125. And I'm not seeing a number that they share. So what I'm going to do is I'm going to simplify this root 48. And what you can do is you can simplify the square root of 48 on a scientific calculator. Not on Desmos, but on a scientific calculator. I'm just going to do it by hand just for the sake of the video. So square root of 48, I'll do it over here. We're going to break it up into its the largest perfect square that goes into it. The largest perfect square that goes into it is 16. So we put that on the left. And then 16 times what gives you 48? It's 3. Now the square root of 16 is 4. So this guy is equal to 4 root 3. So we're going to change this into 4 root 3, the 5th root of 81. And now, oh, wait a minute. If I know my power table, I see that 3, I can write both of these with a base 3. 81 is 3 to the 4th. So now I'm in business. Now what I can do is I can change these the bth root of x to the a is equal to x to the a over b. So like the implied root is 2 and the implied exponent is 1. So this is 4 times 3 to the 1/2 times 3 to the power over root 4/5. Now we're going to, when we multiply by a common base, we add. So we need to add the 1/5, 1/2, and the 4/5. You can do that on a calculator. You can do it by hand really quick. It doesn't matter. You should get, for 1/2 plus 4/5, should get 13 over 10. So I'm going to rewrite this as 4 times 3 to the 13 over 10. Now what I like to do is I like to write this as a mixed number. So 13/10 is 10 goes in one time, and then 10, and then to 13. So there's 3 left over. So it's 1 3/10. So I'm going to use that to split it up. So watch, 4 times 3 to the 1 times 3 to the 3/10. So now we get 4 times 3, that's 12. And we're going to rewrite this guy using a root. Remember, the number on the bottom is the root. So this is the 10th root of 3, and the power is on the top. This one is the power. 3. So 12 times 10th root, 3 to the 3. 3 to 3 is just 27, so this is 12 10th root of 27. And now we should be in business. Let me just check. Yeah, everything looks good. So do you see how in the question it says, rewrite it like this, what is A plus B plus C? So we're going to, let me just hold that up next to it so you guys can see what I mean. So you see A is 12, B is 10, and C is 27. So A plus B plus C is equal to 12 plus 10 plus 27, which is equal to 49. That should be our answer. A lot going on in this question. You got to know how to simplify radicals. You got to know how to go back and forth between radicals and fractional exponents. And you got to know your rules of exponents. So lots of stuff you got to know here. Also, it doesn't hurt to know your power table, at least for like the smaller numbers, like 2, 3, 4, 5. You probably want to know those. They're probably not going to ask you for like a power table of like 9, but you might see 2, 3, 4, maybe even 5. Great, let's keep going. Okay, so we got a statistics question. And it's asking us about the largest possible value of the median. And we'll worry about all this stuff in the middle in a little bit, but the very first thing I do when I see a histogram, and this stinks because you guys can't do this on a digital test, so you might want to copy it down on your paper, is I write the numbers, the frequency on top of the bars. So watch. I'm going to put a 5 here, and then 3, 5, 2, 7, and 4. And it seems silly to do that, but when you're solving the question, you don't have to go back and forth and read the chart on the left, like the axis on the left, a ton of times. So it's way better if you write it down. Okay, next I noticed that they tell us that there are 26 integers. Okay, so that is my sample size. That is my n. So I'm going to write that down. N equals 26. You also could have gotten that by adding all these up. You should get 26 if you do that, but why bother? They told us, right? Like, why would I waste my time adding all those up when they already told us? And now to find the median, we're going to use the position of median formula. So the position of median formula, definitely want to know this for your test, is n plus 1 divided by 2. I'll put a big box around that. So 26 plus 1 divided by 2. That's 27 divided by 2, which is 13.5. So if you got a whole number like 10, that tells you the median is the 10th number. But if you get a decimal like 13.5, it lies in between the 13th and the 14th. So you have to take the average of the 13th and the 14th number. So that's what this question is testing you on. Now we're pretty much in business. So I'll put that average of the 13th and 14th number. So now we have to go to the chart and figure out what the 13th and 14th number are. So let's do that. So what you can do is you can just like cumulatively add until you hit 13. Why don't I go through it like meticulously, and then we can maybe do it a quicker way. So the first box has the first number in it. And then it also has 5, so it has 1 through 5. Hopefully kind of obvious. If we ended at 5, the next one's going to start at 6. And that one goes until, even if you're not sure what to do, guys, just count on your fingers. 6, 7, 8. So that goes to the 8. That goes to 8, and you see how from 5 to 8 we added 3. That's kind of where that comes from. Okay, so the next one, we went to 8, so now we're going to go to 9. Okay, 9, 10, 11, 12, 13. I think it's the 13th. And then 13th, we go to the 14th. 14, 15. Okay, so to the 15th. Then we start on the 16th. And we go 16, 17, 18, 19, 20, 21, 22, 23. And then this one has 24, 25, 26, 27, up to 4. 24, 25, 26, 27. I think I did something wrong. 3, 9 to 13, 9, 10, 11, 12, 13. That's 5. 14, 15. That's 2. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Let me see. Okay, yeah, I see. I accidentally did 8 here. It should be 22. 15 plus 7 is 22. Good. And now we do 23 to 26. 23, 24, 25, 26. That's 4. Good. So you see the first bar contains 1 through 5. The next bar contains 6 to 8. The next bar. Again, you really don't need to go through all that. What I always just do is I just add cumulatively. So like I just get out my calculator and I go, okay, what's 5? 5. Okay. I haven't hit 13 yet, so I must have to keep going. So now let's add cumulatively 3. 5 plus 3. 8. Okay, I haven't hit 13 yet. I got to keep going. 5 plus 8 plus 5. Oh, we hit 13. Okay, so the 13th must be in here. And now I keep going and I add again and I do plus 2 and I go, oh, I just captured the first 15. So if I went from 13th to 15th, the 14th must be in that box. So we got a little unlucky that they weren't just in the same box because that would make the problem a lot easier. But the 13th is in the third box and the 14th is in the fourth box. So now what the heck are they? Well, you see it says all this business about integers greater than or equal to 70 but less than 75. So in other words, what you're going to do is the number on the left is included. So like this bar, for example, it has 70, 71, 72, 73, 74, and then the number on the right is excluded. So it's 70, 71, 72, 73, 74. Then you come over here, it's 75, 76, 77, 78, 79. Stop. Then you go to the next one, and it starts at 80. So if we go to the third box, the possible values are 80, 81, 82, 83, 84. And then for the fourth box, the possible values are 85, 86, 87, 88, 89. And it wants the largest possible value of the median. So we're going to maximize those numbers. In other words, pick the largest possible one. So we're going to go with 84 and 89. And now, because it's the average of those two, we have to average them. To average two numbers, you just add them up and divide by 2. So the median, the largest possible value of the median, we add them up, divide by 2. 84 plus 89, divide by 2. Let's see what that gets us. Should get 86.5, and that is the answer. I think also the fraction form 173 over 2 would work because that's 5 characters. But I would just put 86.5. I think that's easier. Great. Okay. Let's go over this one. So this one is really tricky. This is testing us on the product of solutions formula, the first half at least. So really quickly, for a quadratic, you have to know these two equations. So the sum of the solutions is negative b over a, and the product of the solutions is c over a. They expect you to know that. You need to have those memorized. It's not on the reference sheet. So we're going to write down ax squared plus bx plus c equals 0. And we want to do the product of solutions formula. Let's first write down what a, b, and c are. So a, and I'm going to put air quotes around it so you know I'm talking about a different a. A is negative 2, b is 8, and again, you guys kind of see how I'm getting this. C is this whole thing, negative b over a. Okay, so the product of solutions is c over a. So they tell us that the product is 5/7. So let's kind of plug that in. And then c is negative b over a. And then a is negative 2. So these negatives, negative divided by negative is positive, those cancel out. And then b over a, that's just, let me move this over a little bit so that we have some room to finish the rest of the question. And now b over a divided by 2 is b over 2a. Now we can cross multiply, so 10a equals 7b. And you'll see why I'm doing this in a second. Why don't we get b by itself? So we're going to divide both sides by 7. And we get b equals 10/7 a. That's really important. I'm going to put a box around it. So the reason I'm doing this is because the question wants us to relate a and c. So my strategy is going to be, wait a minute, like we know something about a and b, and we know something about b and c. So you guys kind of see how b is like the middleman. If we get them both equal to b, we can set them equal. And that's what I'm going to try to do. Hopefully it works. Okay, so now we got to use this second piece of information. The number b is, so let's break this down. This is words to math. The number b, okay, so I'm going to write b is, okay, so that's equals 64% less than the number c. So for this one, we need to do a percent multiplier, 1 plus or minus r. Or if you remember from my slides, I said 1 plus the percent divided by 100 and 1 minus the percent divided by 100. Because it says the word less, that's a decrease. So we're going to do 1 minus the percent divided by 100. And I would always just do this really quick on a calculator so you don't make a mistake. It's really stressful to do decimal math in your head when you only have like a minute. So the percent multiplier for this question, we did minus instead of plus because it said less. That's a decreasing word. If it said more, we would do 1 plus 64 divided by 100. So our percent multiplier is 0.36. So we're going to write the equation b equals 0.36c. So let's do that. So now we want to relate a and c, but you see, oh, now I got b equal. So we're going to set those guys equal. So let's do that over here. So 10/7 a is equal to 0.36c. And we want to figure out, we want a is something, right? So we want a by itself. So we're going to divide both sides by um, 10/7. So let's do that. I think I can just put, yeah, that'll work. Okay, so we get A, if we divide both sides by 10 over 7, we get A equals 0.252 C. And that is really important because you see that this is almost kind of like, let me rewrite this. Watch, C times 0.252 equals A. This is like original times a percent multiplier. And notice how equals final. And do you see how the 0.252 is the percent multiplier? And that's a good sign that we did it right because the question says P% less. So that means we should get a percent multiplier between 0 and 1, which we did. So that's our percent multiplier that relates transforming C into A. And remember what I said, guys. A really quick way to change a percent multiplier into a percent change is to just subtract 1 and then multiply by 100. So let's do that. So we're going to do 100 is 1. And we get negative 74.8%. So let's go back over here. So we get negative 74.8%, which is a 74.8% decrease. So P, the percent decrease that they're asking for, is 74.8. So that's our answer. So you see, I kind of combined two questions on this one. The sum and product of solutions formula and the how to relate like two different constants using percent change and algebra and words to math, all that good stuff. So a lot going on in this question. Very tricky question. I think that one looks good. Another way you could do this one, guys, is you could just come up with a number for like do the first part and then come up with a number for A. Like let's say pick a number divisible by 7, like let's say 35, and then you get B is 50, and then you go and find C and then relate them. That would work as well. Don't be afraid to try this one a slightly different way. Okay, let's keep going. Okay, this one's not so bad, and Desmos is actually really helpful for this one, but we're going to do it all by hand just to practice. Whenever you see a projectile quadratics question, there's three kind of really important points you got to be aware of. The initial height, which is the y-intercept, the maximum height, which is the vertex, and the time it takes to reach the ground, which is the positive x-intercept. So do you see here, this first part tells us the positive x-intercepts. And this second part, remember I said the maximum tells you the vertex. So this guy tells you the vertex. So x-intercepts always have y of 0. So hits the ground at 16 seconds. So that's the point 16, 0. And then time is always x. So this one, it's not 1296, 7. It's 7, 1296. And the vertex, we call the coordinates h and k. And whenever we have the vertex of a quadratic, we probably want to use vertex form. So we're going to use vertex form, y equals a. This is not on the reference sheet. You got to have it memorized. Times x minus h squared plus k. So we plug in h and k. We don't know what a is. X minus 7 squared plus 1296. And now we're going to plug in the other point in for x and y to try to find a. So we get y is 0. A, x is 16 minus 7 squared plus 1296. Subtract 1296, 16 minus 7, and then square it, 81. So you should get negative 1296 equals 81a. Divide both sides by 81, and you should get negative 16, which is actually often the A for these problems on the SAT, especially when the units are feet and seconds. That's how it's supposed to work out. It has to do with acceleration on Earth. But again, don't maybe you might want to memorize it, but don't count on it. It's a good thing to know if you're low on time, right? You should do it out, but it's a good thing to know if you're low on time. Okay, so that's our equation now, and at this point, just go straight to Desmos, but let's do the rest by hand just for the sake of practicing the algebra. So what we're going to do is the question wants us to find when does it first reach a height of 972 feet. So remember the height is y, so we're going to make the height 972. And we're going to try to get the square by itself. So you can just kind of pretend this is like a big variable. So we got a negative 16 and a 1296. We got to move the 1296 first. So we're going to subtract 1296 from both sides. We get negative 324 equals negative 16 x minus 7 squared. Now to get rid of that negative 16, we got to divide both sides by negative 16. And we get 20.25 equals x minus 7 squared. Now we have to take the square root of both sides. And we get x minus 7. And the square root 20.25 is 4.5. But don't forget, guys, when you take the square root of a square in an equation, you got to put a plus or minus on the other side. So we're going to now come over here, and we're going to break this up into two equations. So how about we do negative 4.5 equals x minus 7. And then we're going to do positive 4.5 equals x minus 7. So for both of them, we're going to add 7 to both sides. And we get x equals 2.5 seconds. And we get 4.5 plus 7 is 11.5. X equals 11.5. And we want the one that it first reaches it, so the earlier time, which is 2.5, so that is the answer. Lots of people would have forgot to put a plus or minus, and they would have put 11.5 as the answer. Regardless, once I got to this point, I mean, I'm sure you could even do some of this stuff at the beginning with Desmos, but it wasn't that bad, right? It's just stuff you got to know. But we would just do this on Desmos, so that's what we're going to do right now. So give me a second. It's kind of hard because I made my Desmos window really tiny. But you guys kind of see, like, the window's really bad, but you guys kind of see, like, oh, this is like kind of the drawing Kyle had. And what did I say? 972. And then we can come over here and you can see that it hits it at the beginning first on the way up at 2.5, and then it hits it on the way down at 11.5. So that would have saved you, just literally just graphing that equation you came up with would have saved you so much time. So please, on the actual test, do that. So the answer is 2.5. You could also put 5/2. Great, let's come back over here. We just got one more. Okay, this one's asking us about a special right triangle. And we are going to with the magic of television, pull that from the reference sheet. And it's asking us about perimeter and area. So what I'm going to do is I'm going to use this to derive the formulas for perimeter and area. So let me move this a little bit more over to the left. Okay, so the perimeter, we just add up all the sides, right? So x plus x root 3 plus 2x. X plus 2x is 3x. And now I'm going to factor out the x. So the perimeter is 3 plus root 3 times x. And you don't have to have that memorized. You see, you can just look at it and figure it out on your paper pretty quickly. It's probably good to be familiar with this. And I'm going to make a video very soon about this. But you don't need to memorize this by any means. Just know that you should be thinking about the special triangle. Okay, so now for the area. The area of a triangle is 1/2 base times height. So the base is x root 3. And the height is x. And if we simplify that, we get root 3 over 2 times x, which is x squared. So both of those are pretty important for this question. Okay, so they tell us the perimeter is 18 plus 6 root 3. And if I put that here, and you can do this kind of like radical math on your, if you have a scientific calculator that can handle radicals. But we don't really need to do anything for this one. Do you guys see that this times 6 gives you, you see you get 18, and then you get 6 root 3. So x is just 6. If you want to go and type 18 plus 6 root 3 divided by 3 plus root 3 on your scientific calculator, or if you want to do that by hand, by all means do that. But I would hope they would give you a pretty nice number a lot of the time. Okay, so if x is 6, we can now find the area using this equation. So we're going to do root 3 over 2, 6 squared. 36 divided by 2 is 18, so the area is 18 root 3. And the question wants us to round to the nearest hundredth, so we can just go and type in 18 root 3 on Desmos or on your calculator, and rounded to the hundredth should be 31.18. And that would be the final answer for this one. Very good. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.